Here are the notes for section 5.1, the fundamental identities. So identities, statements like the tangent of theta equals sine theta over cosine theta, and cosecant theta equals 1 over the sine theta are trigonometric identities because they are true for all values of the variable for which both sides of the equation are defined. So the set of all such values is the domain of validity of the identity. So here are some basic identities. So you have the reciprocal identities. Cosecant is the reciprocal of the sine, secant is the reciprocal of the cosine, cotangent is the reciprocal of the tangent, or vice versa. Down here, we've got the two quotient identities. The tangent is defined as sine divided by cosine, and the cotangent, since it is the reciprocal of the tangent, is the reciprocal cosine over sine. You also have what's referred to as the Pythagorean identities, so-called because they look like the Pythagorean theorem, a squared plus b squared equals c squared. So cosine squared plus sine squared is equal to 1. If you divide both sides by the cosine, you end up with this equation. Cosine squared divided by cosine squared would give you 1 plus tangent squared equals secant squared. And if you divide both sides by the sine squared, you end up with this version. Cosine squared divided by sine squared is cotangent squared. Sine squared divided by sine squared is 1, so on and so forth. So they're all a version of this. Now, you can also rearrange these, like this could also read cosine squared theta equals 1 minus sine squared. Those are all valid things. Okay, so find sine theta and cosine theta if the tangent of theta is equal to 5 and the cosine is greater than 1. So we could do this by drawing a reference triangle. I'm actually going to use the identities though. So I know tangent theta is 5, so I can actually use this middle row. So 1 plus 5 squared is equal to the secant squared. So this is 26 is equal to the secant squared, which means the square root of 26 is equal to the secant. And secant's the reciprocal of the cosine, so 1 over root 26 is equal to the cosine. So there's cosine. Now to find sine, I'm going to just use the quotient identity. Tangent is equal to sine over cosine. So tangent is 5. Sine over cosine. Where was I? Lost where I was. 1 over root 26, so I would multiply both sides by the 1 over root 26. So 5 over root 26 is equal to the sine. So there's sine, there's cosine. Now, as always, you could have done this with a triangle. Tangent is opposite over adjacent. So 25 squared plus 1 squared, take the square root, so there's root 26. Sine is 5 over root 26, cosine is 1 over root 26. But the identities do also work. All right, here we have what's referred to as the cofunction identities. So this is why things are called sine and cosine, tangent and cotangent, secant and cosecant. Because what's true for the cofunctions, sine and cosine, is that if the angles are complementary, meaning they differ, they add up to 90, they're equal to their cofunction. So like the sine of 30 and the cosine of 60 have the same value because those angles add to 30 and they are cofunctions. The same thing would be true for the tangent of 30 and the cotangent of 60. The angles are complementary, so these cofunctions have the same value. So for complementary angles, cofunctions share the same value, as long as your angles add to 90. You have even odds. So sine is an odd function because the negative can come out front. Same thing for cosecant. Cosine and secant are even functions. Tangent and cotangent are also odd functions. So these functions are even, and these guys are odd. Okay, so if cosine theta is 0.34, find the sine of theta minus pi over 2. So this is actually out of order from this guy. But the sine of theta minus pi over 2 is equal to the negative sine if I reverse it, because it's an odd function. So if I multiply this by -1 to reverse the sign, I can just put the negative sign out front. So, and this stuff there, well, according to the cofunction identity, that's the cosine. So this is negative cosine theta. So the sine of theta minus pi over 2 is equal to the negative cosine of theta. But I know what this is. The problem tells me what it is. So sine is negative 0.34. Okay, So down here, simplify the expression sine cubed x plus sine x cosine x squared. So we're going to use some Pythagorean identities to solve this. We're going to do a little bit of factoring. So if you notice, both terms have a sign, so I can factor a sine x out, which leaves me sine squared x plus cosine squared x. This is a Pythagorean identity. It's equal to 1. So this is sine x times 1, or the whole thing is just sine x. And that's my answer. All right, example 4. Simplify this expression, so I'm going to rewrite it so it actually looks like the fraction it should. So this is secant x plus 1. Oh, I lost an x. Secant x minus 1 all over the sine squared. So I can FOIL on the top. Now that is a difference of squares, so I don't have to worry about the outside, inside parts of the FOIL. It's going to be secant squared x minus 1 over sine squared of x. So let's see here. That's probably up there on top. The Pythagorean identity. Let me grab the sheet again so I can point it out. It's actually a version of this one right here. If I move this 1 across, tangent squared is equal to secant squared minus 1. So this is the tangent squared over the secant squared. So what I can do now is I can kind of take this apart and write everything in terms of sines and cosines. So I'm going to rewrite this. I'm going to pull the tangent out front, 1 over the secant squared. So like that. So, oh no, I don't know why I put secant sine there. That should be sine. There we go. So tangent squared is sine squared over cosine squared, because tangent is sine over cosine, so if it's tangent squared, it's sine squared over cosine squared. And I still have this 1 over sine squared hanging off. Sine squares can cancel, which gives me 1 over the cosine squared, which is the same thing as the secant squared. So there's my answer. All of this mess simplifies to just secant squared. All right, simplify this expression. So let's see here, we got cosine of x over 1 minus sine x minus sine x over cosine x. So to combine two fractions, I need a common denominator. So this one has to get multiplied by the 1 minus sine x. This one has to get multiplied by the cosine x. So this first fraction becomes cosine squared x over cosine x. We're not going to FOIL that out just yet, just in case something can cancel. Over here, I'm going to have sine x minus sine squared x all over like that. Okay, so now I have a common denominator. I can do my fractions. So cosine squared x minus sine x. Now be careful, that's going to be plus sine squared. This negative sign goes there as well. And on the bottom, cosine x, 1 minus sine x. Now, even though they're separated, I have a cosine squared plus a sine squared, so these two terms here combine to make 1. So I have 1 minus sine x over cosine x times 1 minus sine x. So this 1 minus sine x can cancel that 1 minus sine x, leaving me 1 over cosine x, which is just the secant quotient or reciprocal identity. Okay, example 6, solving. Find all values of x on the interval 0 to 2 pi. To solve, cosine cubed x over sine x is equal to the cotangent. So cosine cubed x over sine x is equal to the cotangent x. So the first thing I'm going to do is write everything in terms of sines and cosines. So cotangent is cosine x over sine x. Now if you notice, I got sine x on both bottoms, so I can get rid of those guys. So this is going to be the same thing as cosine cubed x equals cosine x. So I'm going to bring everybody left. Cosine cubed x minus cosine x equals 0. I could factor a cosine out now. So this would be true. So since this is a product, this, I think, can simplify. Where's my Pythagorean identity sheet again? Lost it. Cosine squared x minus 1. So here, if you look at this guy, if I bring this 1 across, move that sign across, I get cosine squared minus 1 is equal to the negative sine squared. So I can replace this with the negative sine squared. Okay, so since I have two factors, I set them separately equal to 0 and solve them. So this one, I'm looking for where on the interval 0 to 2 pi, the x, remember cosine, so is 0. So this one occurs at either pi over 2 or 3 pi over 2. There are two angles that have a cosine of 0 in that interval. I'm over here, multiply by -1, take the square root, so I'm looking at sine x is equal to 0. The problem is I can't use this, because if sine x is 0, the original problem doesn't work. So these two are the only values that work. If you solve this, you'll get 0 and pi, but if you check your answers, 0 and pi do not work in this equation, because they force you to divide by 0. So they are extraneous solutions. Okay, so down here, find all solutions to the trigonometric equation, 2 sine squared x plus sine x plus, or equals 1. Sorry. So this one looks, honestly, kind of like a quadratic. Instead of x squared, you have sine squared. So I'm going to bring everybody to one side first. And then I'm going to try to factor it. So to get -1, I have to have a -1 and a +1. So we'll put 2 sine here, and we'll just put sine here, and check and work. So there's 2 sine squared, there's +2 sine, minus 1 sine would be +1 sine overall, -1. So once again, I have two factors. So I'm going to take my factors separately, equal to 0. Oops, +1 equals 0. So this one would become sine x equals 1/2. Add the 1 across, divide by 2. This one would become sine x equals -1. So this only has one solution. 3 pi over 2 is the only location that has a y value of -1. A y value of 1/2 occurs at pi over 6 and at 5 pi over 6 on the unit circle. Now the thing it says find all solutions. Now since sine is periodic, solutions repeat every 2 pi. So the solutions are pi over 6 plus 2 pi n, 5 pi over 6 plus 2 pi n. So this is n is for the multiple of 2 pi, and 3 pi over 2 plus 2 pi n, where n is equal to 0 plus or minus 1 plus or minus 2, so on and so forth. These ones all solutions, not just, we didn't have to do that up here because we were restricted to our interval, only angles between 0 and 2 pi. So we start by finding the 0 to 2 pi's and then use the periodicity to find the rest of the solutions. All right, and our last one, number 8. Find all solutions to the equation cosine t equals 0.7 using a graph where needed. So this is not a useful trig identity, so I'm going to have to look at the graph. So what I'm going to do is, if I look at the graph, when you graph trig functions, you need to make sure you are in radian. So that's what I was just checking there. So we don't need this equation. So the cosine of x, and we're going to set it equal to 0.7, and we're going to draw it. Oh dear. Okay, view window, trig. We'll reset it here. There we go. So actually, I'm just going to look at these two here because this repeats, so I can use the same trick as before. So gsolve intersection. So I don't want that. We'll pick this one. So you have one solution at about -0.80, and then the other one here is at positive 0.80. But since it's periodic, they're going to differ by 2 pi n's. So if you look over here, this one right here, 5.48, is about 6.28 plus that number. Because 2 pi is about 6.28. The next one here is a little bit more than 7 because 2 pi is 6.28 plus 0.8 is 7.08-ish. So those are your solutions. It says find all, you have to have this repeating thing. So n is equal to 0 plus or minus 1 plus or minus 2, blah, 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 so on and so forth. Which brings us to the end of the section.